Okay, hi friends. So I'm going to review long division again because I know there was some confusion about that. So let's just get right into it. So that mnemonic that I was teaching you last night, I'm going to write it out now. Please forgive me because I am writing with a mouse. But it's does McDonald's. Sorry, this is taking me a moment. So, burgers raw. So like I said, the first letter of each of these words represents one of the steps of long division. So D, that's going to be divide. Let's see if I can make a division symbol. There we go. And then McDonald's is for multiply. S in cell is for subtract. The B in burgers is for bring down. And raw, or the R in raw, is for repeat. So the steps of long division is divide, multiply, subtract, bring down, repeat. So now we're going to go ahead and do a little long division problem. We're going to go through these steps really slow. I'm going to really try and explain myself. So let's see, let's think of some numbers. Let's do 100. So this is our dividend inside of our long division bracket here. And I'm going to make our divisor 3. That's going to go on the outside. So remember we have dividend and that gets divided by the divisor. And our answer is the quotient. And again, please forgive my really poor handwriting right now with this mouse. So remember when it's linear, we're going to kind of, when it's linear like this, I'm going to write that out. Linear or horizontal is how I'll sometimes call it. It's going to get flipped around when we put it into this long division form like this here. Our dividend goes on the inside. Our divisor goes on the outside. Probably could have written that a little bit closer, but I want to make sure I have enough space. And then our quotient, our answer to a division problem, goes on top. So now that we have a little bit of vocab out of the way, we have our little mnemonic device right here, which again, like I told you yesterday, I've made a poster for this and that will be up in the classroom by our next class together on Tuesday. So yeah, let's get right into it. So our first step is, let's see, can I change my colors? Ooh, I can't change my colors. So my 3 right here, this is my divisor. I'm going to be working with this 3 a lot. So for division, like I said, you kind of want to ask yourself how many times does it fit? We want to know how many times does 3 fit inside of whatever number we're looking at. So does it fit? Sorry, y'all, this is a little bit messy. As well, if you look in that lesson 1 April 24th folder on Blackboard, you will see those notes that I wrote, and I go through long division there as well. I did not write down this mnemonic there, I just explained the steps really in depth. But if you want this kind of memory device to help you out, please continue watching. This is just another way to show you how to remember the steps for long division. I found with a lot of my previous students, they sometimes got a little bit mixed up in what they were doing. But just like with a lot of math, everything just repeats. So once you feel comfortable doing this a few times, you should be able to do long division with any kind of problem. So anyways, let's get back into it. I have my 3 here. I'm going to switch back to my black. So I want to find out how many times 3 fits into 1. Now 3 is larger than 1, so it's going to fit in there 0 times. I'm going to put a 0 on top. And I didn't show this last night, I'm showing it now. I figured just for the sake of clarity, it might help you understand a little bit more. So I just divided, that's my first step. I just divided. I asked how many times does 3 fit in 1? Fits in there 0 times. So I put a 0 on top of the number I was working with, which is 1. Now I can move on to my second step, which is multiplying. So now I'm going to take that number that I just divided and got, which is 0. I'm going to multiply that by 3. 0 times 3 is just 0. Any number times 0 is just 0. So now I've multiplied, I can move on to my third step, which is subtracting. I'm going to subtract 1 and 0. I'm going to find the difference. 1 minus 0, identity property, that's just 1. Now I can go to my fourth step, and that's bring down. So I'm going to bring down my next number, which is 0. And now my fifth step is I'm just going to repeat everything that I just did. So I go all the way back up here to step number 1. I'm going to divide. I'm going to ask how many times does 3 fit inside of 10 now? So now I'm looking at a 2-digit number 10. How many times does 3 fit in 10? That's going to be 3 times. 3 times 3 is 9. I can't do any more 3's because they won't all fit inside of 10. So I put my 3 there. I go to my second step. 3 times 3 is 9. I just told you that. Now I get to go to my third step and subtract. 10 minus 9 is 1. I go to my fourth step. I bring down my 0. And looky there, we have a 10 again. I did this on purpose because I wanted to show that decimal division again. I'll show you remainder as well, and then we will move into that decimal. So I just brought down my 0. I'm going to repeat and move back to step 1. I'm going to ask myself yet again, how many times does 3 fit into 10? Well, we just figured that out, so this is going to be easy peasy for us. We know 3 fits into 10 3 times. So I put my 3 up here, and I go into my second step of multiplying. 3 times 3 is 9, so I can write that down here, and go to my third step and subtract. 10 minus 9 is 1, and that's that. I have a remainder. So like I was talking about last night, there's 2 different ways we can deal with remainders. You may have seen before in elementary or middle school that you can write 33R, which stands for remainder 1. So this is one way, so this is one method. So I'm going to call this the remainder method. I hope you guys can't hear me breathing awkwardly as I do this. Remainder method. So that's going to be 33. So we got as far as we could with this. There was a number left over. So then we put remainder and that number that was left over, because there's nothing else for us to bring down. We can't keep dividing if we use this method. However, let's see, let me erase this. Oh, that was a really cool eraser. This is my first time using this whiteboard app, so I'm kind of having fun with it, I'll be honest. So our second method is going to be the decimal method. And let me just have a moment to write this all out. There we go. And with that, what we're going to do is we're actually going to create a decimals place inside of our dividend here. So I'm not changing the value of this. 100 is equal to 100.0. They're both the exact same thing. I'm just creating a way for me to represent this remainder as a decimal, which we could also change into the form of a fraction if that helps us more. So this is the exact same thing as 100. I'm not really creating a new number here. I'm just making a way for me to find a decimal. So when I make a decimal, I saw there's a highlighter here. Oh, I make a decimal, I'm going to put it in the exact same spot in my quotient. So I just carry my decimal straight up. and it goes in the exact same spot as where my quotient is. So now I've made a new 0 that I can bring down. We just subtracted. Now we can go to our fourth step and bring down this 0. Oh, that was not a pretty, hold on. Alright, I don't know if that's better or not, but we'll just roll with that. And now I can repeat again. So I can divide. How many times does 3 fit inside of 10? We've just been doing this. This is going to be a repeating decimal, which I would like to talk about as well. I think they're kind of fun. It's called an irrational number, kind of a fun concept. So now, how many times does 3 fit in 10? Well, we've been doing this. We know it's going to be 3 times. Now I can go to my second step. I can multiply. 3 times 3 is 9. And now I can subtract. My third step, I'm going to subtract. 10 minus 9 is 1. There's still a remainder, so I can create as many zeros in my dividend as I need until I either realize there's going to be a repeating pattern or until I finally get it to where I don't have any remainder. So I bring down my 0. I'm going to repeat again just to go through these steps another time. So I go back up to division. I'm going to ask myself, how many times does 3 fit inside of 10? I don't know if this is getting repetitive yet, but we know it's going to be 3 times. So I put my 3 up here above that 0 I just created. Now I go to my second step and multiply. 3 times 3 is 9. I can go to my third step and subtract. 10 minus 9 is 1. And now we can very clearly see it. This is just going to keep repeating. I'm going to keep getting 3's here forever and ever and ever, and I'll never be able to stop, and I'll have to keep dividing until, at the end of time. So we could keep doing that, or once we realize that there is a repetition happening, what we can do is we can write our answer. So let's see, I'm going to make a little space over here. So we're going to call this an irrational number. Are there 2 R's in that? I don't know. Can I spell? I think it's just this, irrational number. Man, my handwriting is atrocious on this. Maybe I'll get better as I keep filming videos for you guys. So irrational number. Ooh. That just means it keeps repeating. The same pattern. So it's going to be a pattern. It's not always going to be, the same number repeating over again. You might realize it's going to repeat 2, 7, 2, 7, 2, 7 for infinity. So it keeps repeating the same pattern forever. And how we can represent this is we take our whole number portion, 33, and then I take my decimal portion, which I know is just going to be 3, and I draw a line above my decimal portion. That tells me and anyone else who sees this number right here that this 3 just keeps going and going and going and going. It's going to be 3's forever and ever. Now you may have also seen this represented as in fraction form as 1/3. 1/3 is equal to the decimal 0.3 repeating. That's how we read this. 0.3 repeating. 33.3 repeating. Alright, y'all, should we do one more problem? Let's see, I think we should. I'm going to, I'm having fun, y'all. I don't know what this is going to do. Oh, I can scroll down? Okay, guys, I'm having such a fun time with this. Okay. Can I scroll down more? Oh, I guess I could zoom out. It's not exactly what I wanted, but I guess we'll zoom out a little bit. Let's see. How do I go back to more? Oh, okay. Well, I have to pay for that. That's not fun. There we go. Okay. Let's do another example off to the side over here, I guess. So let's see. Let's do the problem 27 divided by 6. 27 divided by 6. So when I set this up, I'm going to put my dividend inside of my long division bracket. So 27 is going to go on the inside. And I'm going to put my divisor, my second number, on the outside. My divisor is the one doing the division. It's splitting up my 27 into 6 pieces. So now, let's find our new quotient for this problem. So we have no idea what this is going to equal currently, but we'll find out together. There we go. So now, let's ask ourselves, how many times does 6 fit into 2? Well, 6 can't fit in 2 because 2 is less than 6, so it's going to be 0 times. So now I can go to my second step of multiplying. 0 times 6 is 0. Like I said, anything multiplied by 0 is just going to be 0. Now I go to my third step and subtract. 2 minus 0 is just 2. Now I go to my fourth step and bring down my 7 here. And we're just working with 27. So once you start getting more comfortable with division, you might realize, oh, I don't have to write my 0 here. I can just start with the 27. I can skip all of this right here. Whatever works best for you. If you prefer to start with this just so that you don't get confused, you can clearly see all of your work and what you've done, I highly encourage you to do that, whatever you're most comfortable with. So now we are going to repeat. How many times does 6 fit into 27? That's going to be 4 times. 4 times 6 is 24. Long division can be difficult if you are not very comfortable with your math facts. So if you want some support with your math facts, I am more than happy to provide you resources for that. Or even I can integrate something into class if we're all feeling like we want practice with that. We can practice our math facts together. But continuing on, so we just divided. How many times does 6 fit into 27? That's 4 times. Now we, second step, multiply. You can kind of combine these steps once you start to feel more comfortable, because as you noticed, I said 6 fits into 27 4 times because 4 times 6 is 24. If I added another 6 to that, I'd get 30, and 30 is too big for 27. So if you wanted to, you could get on your calculator on a piece of paper, say, okay, 6 times 1 is equal to 6. 6 times 2 is equal to 12. I can still fit more 6's. 12 is less than 27. 6 times 3 is equal to 18. Oh, we're getting close now. 6 times 4 is equal to 24. Maybe we can fit one more 6. Let me check. 6 times 5 is equal to 30. Oh, that's larger than 27, so I can't fit 5 6's in 27. It's going to have to be 4 6's. So that's what I did in my head, but if you need to use a calculator or write it on your paper, whatever it is you may do, you can skip count as well. You could, I can show you guys in class if you aren't familiar with skip counting. Please feel free to ask me about that. But yeah, we just found out we know we can fit 4 6's in here, and we know that 6 times 4 is going to get us that 24. So now we can go to our third step and subtract. 27 minus 34 will get me 3, and I have a remainder. I did mention this in class, but I do prefer that we create decimals for this, so we're going to create a decimal in our dividend here. I'm going to carry my decimal right up to my quotient, and we're going to continue. So I'm going to bring down my 0, and now we get to go back to step 1. We're going to repeat. So I have to ask myself, how many times does 6 fit in 30? Well, look, I already did all the work over here. I know 6 fits in 30 5 times. So that was a terrible arrow, y'all. There we go. I don't know if that's better or not either. So I can put my 5 up here above that 0 I just created. And now I go to my second step. I multiply. 5 times 6, well, that's 30. And now I go to my third step and subtract. Oops, didn't mean like that. 30 minus 30 is 0. And look, I don't have any remainder, so now I'm done. Now I know that there are 4.5 6's in 27. So now I know 6 times 4.5 will get me 27. Alright, y'all, I hope this was helpful. After this, I'm also going to record a video about order of operations, so please be sure to check that out because I know we were kind of rushed at that point. and I am also going to show you on Desmos. I don't know if you can see my tabs up here. I'm going to show you on Desmos. Some of y'all had a little bit of trouble last night typing in that problem that we did. And you ended up getting the wrong answer, and I corrected it for a couple of you on how to find the correct answer. But when we type math problems into a scientific calculator or graphing calculator, whatever we're using, we have to be very diligent in how we're typing it in. And I'll get into this more with my order of operations video as well. But it's worth repeating a few times. You just have to be very diligent and have a keen eye for detail with math. So yeah, if you have any questions, please feel free to shoot me a message, or you can write down whatever questions you have and we can talk about it in class, whatever works best for you. Good luck, and let me know if you need any support with anything.